So welcome to the next experiment. This is all about boiling water in the microwave, in the kettle and on an induction hob. I'm going to be doing exactly 500 millilitres of water in the microwave, 500 millilitres in a 3 kilowatt kettle and 500 millilitres in an induction pan. And as usual, we're measuring the energy consumption on a energy meter. It's going to show me exactly how many watts and how long it takes. For the induction hob, I don't have an energy meter. I have a CT clamp around the cooker cable, and it's recording the results on my computer in the other room. So this is a Panasonic inverter 1000 watt microwave, and I've set it going on 10 minutes now on full power. I don't expect it to take 10 minutes. I'm going to stop it as soon as I can see the water boiling through the window. Okay, so I need it properly boiling, and I've reset the energy meter to see how long it's going to take and how much power is going to be used. Now, microwaves are notoriously uneven at heating, but hopefully as part of it starts to boil, it will mix the rest of the water and you'll all see it all boiling fairly quickly. So I'm going to rely on that to mix the water around as opposed to stirring it, because I don't really want to upset the process by stirring it. Now on about 3 minutes and 30 seconds, the water is starting to get a few little bubbles in it, but it's definitely not boiling yet. I want to see boiling as in when you see a kettle boil, so it's vigorously bubbling inside there. So I'd say that's boiling now, and that is 5 and 15, so that's 4 minutes and 45 seconds. Okay, so this is a 3 kilowatt hour kettle. If you want it for an hour, use 3 kilowatts of electricity. Now I expect this to be the quickest of all because they're actually one of the most efficient methods of boiling water. When you're boiling water quickly, it doesn't really matter what material the kettle's made of, because the amount of insulation really only matters over a longer period of time. So if it's only going to be a couple of minutes, it won't matter whether it's a metal kettle, glass kettle, plastic kettle, insulated kettle. It really won't make any difference to the energy usage. So I'm just going to swap my energy meter over onto the kettle plug and boil the ½ litre in the kettle. Here we go for the kettle. It's boiling now, and then kettles just overdo it slightly. But this one's pretty good from that respect. So it used 59 watts and took 1 minute and 25 seconds. So I'm going to do the same ½ litre boiling experiment on the induction hob. In this pan, it's a pan designed for induction hobs. I'm going to measure the time on the stopwatch, even though it will also be done on my computer, which has a CT clamp around the cooker cable. So I'm going to put this on P, and I know on P it uses 2.3 kilowatt hours of electricity. Can you do that at the same time with the camera? So I need to turn it off at the same time as well. Turning the hob off is more important when it's boiling than stopping the stopwatch. So I'll look at the stopwatch. In fact, it looks like it's boiling now. So I'll turn that off there. I just missed the stop there by a second, so it took 1 minute 40 seconds. And I'm going to go and work out the energy consumption, which equals 63.5 watts of energy used. The kettle is definitely the most efficient. The kettle used 59 watts of energy, and the induction hob used 63 watts of energy, and the microwave used 110 watts. Thank you very much for watching yet again, and please subscribe if you want to follow any of the videos that I'm doing. I'll see you again soon.